Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope you all are doing really great. So students, in this video we are going to solve the question from the chapter Electromagnetic Waves. Okay, so first let's go through the questions, then we will see basics and all that. So see, the question is the magnetic field of an EM wave is given by this one. You can see vector B equal to some expression is given, and they are asking what is the corresponding electric field in SI unit they are asking. Okay, so before solving this question we should know very well the electromagnetic wave is what. Okay, so remember that here electromagnetic wave is a one kind of non-mechanical wave. Okay, and in this electric field and magnetic field will oscillate and they will be perpendicular to each other. Okay, so you can see very well here electric field is given by the which color? Red color. You can see here this electric field is oscillating in a which plane? The electric field is oscillating in a YX plane here, or we can tell here XY plane. Okay, similarly if you talk about here the magnetic field, this magnetic field is oscillating in a which plane? ZX plane. Okay, now after that students, if we talk about here the amplitude of the electric field in a which direction? Y direction. See, I put the star sign on the Y. And similarly the amplitude of the magnetic field in which direction? Z direction. So I have put the star on a Z. Okay, and the wave is propagating along which direction? It is propagating along the X direction. Okay, and remember that the direction of the electromagnetic wave is always given by E cross B. That means from the right hand thumb rule, when you will curl your finger from E to B. Okay, see here please, this electric field direction along Y direction, this magnetic field along Z direction, and the wave is propagating along X direction here. Okay, and remember that here all these three will be mutually perpendicular here. Okay, so what I have told you, the electromagnetic wave propagation direction is given by E cross B. So kindly see here I have written here the first equation, E cap cross B cap equal to V cap. Okay, like this is there. Now after that here, from here if we see the further things, again if you will apply the right hand thumb rule, you can see B cap cross V cap equal to E cap. Na? So see here please, this is B out of the board, V cap this side, so B cap cross V cap through the smaller angle, E cap will come. Similarly other thing is there, you can see V cap cross E cap. See, V cap cross E cap will give us the B cap, because all these basics are required to solve this question. Okay, and now kindly say here that this wave is traveling along which direction? X direction. Okay, so if I write here the wave equation, so I can write here, kindly say very well, I can write here this EY equal to E naught sine X direction, means I will write here omega t minus kx, and direction, kindly see very well, traveling along which direction? This wave is traveling along which direction? X direction. Okay, so I will write here what here? This one we can see very well here, the amplitude is the amplitude of the electric field along Y direction. So I will write here the J cap, and this X indicates along X direction. Minus X means positive X direction, plus X means negative X direction. If we talk about here the magnetic field, so Bz is given by what? This is the amplitude into sine, you can write the cos also, no problem, omega t minus kx into which direction? Z direction. That means I have to write here the k cap. This basics kindly see here. No? All these things. Now we are going to solve the question. We are ready to solve. Okay. So students, if we talk about here this question, so see here the given magnetic field expression for the electromagnetic wave is given by this one. Okay, so this equation is given. I will compare with the standard equation. So vector B equal to, this is the direction. Okay, I cap J cap. So I will write here, see, this is the direction. They have given the direction front. Maximum they will give the back side, but here they have given front. After that the amplitude of the magnetic field, and here they are writing sine omega t minus Z by C. Okay, so phase is not a problem. Remember that here when we are going to calculate the electric field, whatever is the phase, instantaneous phase of the magnetic field, same will be for the electric field also. Okay, because they will be in a same phase. Okay, the main thing arises for the direction and the amplitude here. Okay, so first one we are going to see here the amplitude. Okay, so kindly see, remember that here we know that the formula is what here? E naught by B naught is equal to C. Okay, this is the general formula. So if I will calculate here the amplitude of the electric field, it will come here B naught into C. Okay, and if you will compare here, this is the B naught is here and this is the 30 is there. Okay, that means what is the value of the B naught? It is the 30. Okay, so I can write here the value of E naught will be how much here? 30 into C. Unit, it will come here anyhow, the Newton per coulomb. See, amplitude we have calculated, not at all problem. Now after that, it comes to the direction now. Now, what is the direction of the electric field? So say here, we know the direction of the magnetic field. No? The direction of the magnetic field is what given? See, this B cap. B cap is given here, this one. Can you say here? Direction, root 3 by 2 I cap plus 1 by 2 J cap. Now, this is the direction of the magnetic field. Now, the wave is traveling along which direction? You can see minus Z by C. That means the wave is traveling along the positive Z direction. Minus Z is given. That means positive Z direction. That means I can write here this V cap is given here, K cap here. Now, so B cap we know, V cap we know. What we have to calculate? We have to calculate here the electric field direction. So, which formula we are going to use here? As I have told you, see, E cap is equal to what we know, B cap cross V cap. This formula I will use here and I will get here the direction. Okay, so see here please, as E cap is equal to what here again? Can you see here? B cap cross V cap. This basic we are using here. Okay, so see here now, B cap cross V cap. Okay, so let's kindly put here the values. So what is the B cap is here? Kindly see here, root 3 by 2 I cap plus 1 by 2 J cap and cross K cap here. Is it? Can you see here? Now we have to just take here the cross product. Okay, so this cross product I will take here now, because here the space is there. So here the students here, this E cap is given here, multiply K cap inside, so it will become here what? Root 3 by 2 I cap cross K cap plus 1 by 2 J cap cross K cap. 1 by 2 J cap cross K cap. Okay. So what this happened right here, here students, root 3 by 2, you know very well, I cap cross K cap will be what here? Remember that here, it will be minus J cap, very basic, plus half J cap cross K cap, it will be how much here? You know, I cap cross J cap, K cap, J cap cross K cap, it will be I cap, and K cap cross I cap will be J cap. Okay, actually the one circle used to be there like this here. This is the plus. I will write here in a anti-clockwise direction. Let's take here, this is the I cap, this is the J cap, and like this is there, K cap. Like this used to be there. I cap cross J cap, K cap. J cap cross K cap, I cap. So what it will come here? It will come here I cap. So see here, this is the direction of the electric field we have got here, root 3 by 2 minus J cap plus half I cap. This is the direction of what is students? Electric field. Now after that, can you see here? If I write the expression here, so see here please, first I will write here the general expression. The electric field expression, it will be given here, as I am telling you, E cap, and here the amplitude into sine same phase, omega t minus Z by C. Okay, now very easy, we'll just put here the values and all. Okay, so hence this electric field is given here. What is the E cap value? You know very well, the E cap value came this one, no? Minus root 3 by 2 J cap plus half I cap. See here please, minus root 3 by 2 J cap plus half I cap here. Now this one here. What is the amplitude of the electric field we have calculated? You know very well here, 30 C, and phase as it is same here, sine omega t minus Z by C here. Okay, so this is the expression of the electric field. Kindly see very well. Okay, so see where this option is matching. No, kindly see here. So when you will see very well students here, kindly see here the first option. What is the first option? See, minus root 3 by 2 J cap plus half I cap, 30 C sine, and this one is there. Okay, so what is the answer for this question? Kindly see very well, the answer for this question is the option A is the answer. As I have told you very well, the phase will be same, magnitude we can calculate very easily. The main thing is there the direction. For that the basic is needed. That I have told you in the starting. Okay, kindly see very well. Now students, in the same video I will just tell you one more question that is came in a same year, but here also the basics are required. Okay, so see here this question. In this question reverse is there. See, the question is the electric field of an electromagnetic wave in free space, that means is vacuum, is given by this one, vector E equal to like that. Okay, and what they are asking here, the associated magnetic field in Tesla is how much here. Okay, can you see here? And here also 4 options are there, 3 options here, 1 option will be next one here. Okay, so basic will be same here. So can you see here, given electric field expression of electromagnetic wave is given by what here? This is the expression here. Okay, so students here, if I will just compare here, see here please, here I will write this. If I will write here like this here, see, vector E equal to, see here please, 57 into cos, let me write here first, 7.5 into 10 to the power 60, I will write in this way, minus, okay. So here what will happen that here, see, 5 into 10 to the power minus 3, I will multiply with 5 because I have to get here the unit vector direction, okay. So see, 3x plus 4y by 5, okay. And after that here, students, here what can I write here, see, 4I cap minus 3j cap by 5. Now we are going in a basic here, into 5, because see here I have divided with 5, here I have multiplied with 5. Here I have divided by 5, here I have multiplied with 5. Why I am doing this? Because I have to get the direction here, okay. So kindly see here, this 57 is the E naught here, okay. And this one, 7.5 into 10 to the power 6 is the omega, okay. And this thing is the value of the k, okay. Now kindly you can see from here, the wave is traveling along which direction, okay. This will give us the direction of the electromagnetic wave that I have written here, the V cap, okay. And this thing, if I write here, see here please, this is student, see, this thing will give us the direction of the electric field, that means E cap is there, okay. So here in the question itself, they are telling this wave is traveling in a free space. Free space means what is the speed here? Speed of light. Even I can prove also. See here please, one by one I will see here. First I will use the speed, then I will calculate here the which expression? Magnetic field expression, okay. So kindly see here, you know very well, V equal to omega by k, is it? What is the value of the omega? Kindly see here, 7.5 into 10 to the power 6 by, what is the value of the k? Kindly see here, 25 into 10 to the power minus 3. So you can see very well, this will go up, so 10 power 9. So I can write here, see, 75 into 10 to the power 8 by 25. What is coming? See, 3 into 10 to the power 8 meter per second. Even you can see also. Why I have shown you this? Because I need the unit vector. I have told you, this wave is traveling not x, y or z direction. Some plane this wave is traveling, okay. So here we have got here the speed. Second one, if I talk about here the, the magnitude of the, which one? Magnetic field we want. So what I have told you, I have taught you E naught by B naught is equal to V actually, V. Here actually V is equal to C, no problem, but this is the basic thing, because the electromagnetic wave in a vacuum it will travel with the speed of light, but if the medium is there, then the speed will be less than the speed of the light, okay. So remember that here if I will write here the B naught, this B naught will be what here? E naught by V, okay. And what is the value of the E naught? You can see very well, this is the 57. And what we can write here? Here we can write here V. What is coming here? 3 into 10 to the power 8. Okay, 3 into 10 power 8. Unit is what here? Unit is the Tesla. Okay, so see, this one we have got here the magnitude of the magnetic field actually. We cannot tell magnitude actually, the amplitude, the maximum displacement, up that one. That sinusoidal wave is there, the maximum. That is the amplitude here, B naught. Main thing is the direction. So see here students, here we have to find out the direction of what? Direction of the magnetic field. See, this is the direction of the wave, overall this. This is the direction of the electric field. We want the direction of the magnetic field, okay. So for that we have to go in a more basic. See here please here. If we want to know the direction of the magnetic field, we have to use this formula. B cap equal to what is this? V cap cross E cap. This one we are going to use, see, from this I have got here. What is the expression? B cap equal to V cap cross E cap. Okay. This one we have done here. See here. So again, we are going to see the next one here. What I am going to do here, see, the B cap equal to V cap cross E cap. Is it? V cap cross E cap, B cap. Now students, what is the direction of the V cap? See, the direction of the V cap is what here? See, 3x plus 4y by 5. This one I will write in a unit vector form. That means 3I cap plus 4j cap by 5. What I am going to write here, students, this is the, see, 3I cap plus 4j cap by 5. Okay, cross. Now, electric field in which direction? Can you see here? Electric field in which direction? See, E cap direction is here. 4I cap minus 3j cap by 5, unit vector way, okay. So 4I cap minus 3j cap, see here please, 4I cap minus 3j cap by 5, okay. So now what will happen that here, can you see here? This 25 will come outside. So 3I cap cross 4 I cap, it will be 0 because I cap cross I cap 0. Now see here, 3 into 3 minus 9, it will become here I cap cross j cap. Okay. After that, 4j cap plus 4 into 4, 16, it will become here j cap cross I cap. Okay. And again, j cap cross j cap will be 0 here. Now, so now see here, students, 1 by 25 minus 9 I cap cross j cap k cap plus 16 j cap cross I cap. You know I cap cross j cap k cap. So j cap cross I cap, it will be minus k cap. Now because it does not follow the commutative law here. So what this will come here, kindly see here, students, 1 by 25, it will become here minus 25 k cap. Anyhow, students, 25 and 25 cancel. This 25 cancel. Okay. So what this will come here, the direction of the magnetic field is given by minus k cap. What is coming here, kindly see very well how I have got the direction. The direction of the magnetic field is how much here? Minus k cap. Okay. After that, if I write here the expression, so expression is given by vector B equal to, kindly see here, I will write here the general expression, B naught into, it is given in a cos form, so cos, anyhow, this is the omega t minus traveling in a which direction, kindly see here, omega t minus this one. See this one, this all the things will be written here. Now, whatever is the phase here, the phase will be same only, phase no change as it is. Now, because they are in a same phase. After that, what will happen that here, I have to write here the B cap, okay. And see here, one more extra 5 is came, one more extra this 5 is came. Now see, this is the count table, we have to remember that here, into 5, this will not left anywhere. So what is the value of the B naught, students? You know very well the B naught value is came here, what you have seen this side here, see, this B naught is the value, 57 by 3 into 10 power 8, right please, 57 by 3 into 10 to the power 8 into cos, here it will be as it is, no change. What is the value of the B cap? It is coming here minus k cap into 5 here. Okay. Now take minus here, so minus 57 by 3 into 10 to the power 8 cos, inside the cos function same as I told you, electric field and magnetic field in same phase, and it will become what here? It will become here 5 k cap here. Is it, students? So this is the magnetic field of the electromagnetic wave. See how I have calculated in a very basic way. Okay. So kindly see here now, which option is correct here? Minus 57 by 3 into 10 power 8 here, and here you can see what is given here, 5 k cap is there here. Let's see further options are also there. Here k cap is given, 5 is not there, is it? So which option is correct here, students? You can see very well the correct option is here, option C is the answer. Kindly see, is it? So students, if I will just go to the starting, so kindly see here. So students, I hope so this video of electromagnetic wave that is traveling in a plane, that is traveling in a plane, that is the beauty of the JEE Mains exam. And here I have taught you this basics, this three points to get the direction. Amplitude calculation very easy. The most important thing is to calculate the direction, is it? So students, see this video very properly and share with your friends also. Keep studying, keep growing.